Today we'll be doing another engineering economics problem. This problem states you want to invest $3,000 every 2 months into an account that gives 4% per year compounded quarterly. How much will you have after 20 years? You make the first deposit on the second month. Okay, so let's draw our cash flow diagram. So I'm going to draw it in a monthly basis. So what we have at month 0 is nothing, and then 2 months later we have our first deposit, and then we wait another 2 months, and then we have our second deposit, and then this repeats until month 240. So the issue with this problem is that we're depositing every 2 months. However, our interest rate is compounded quarterly, so there's this imbalance when it comes to our interest rate and our cash flow diagram. So what that leads us to do is calculate the effective interest rate on a 2-month basis. So what we want to do is convert this cash flow diagram into a 2-month basis so that we have a so-called monthly payment. So now this cash flow diagram is in terms of 2 months. So when I say 1, that is equal to 2 months, and when it's 240, that would be 120. So now this is on a 2-month basis, and now we have a consistent so-called monthly payment, but really it's 2 months. So we could say that this is $3,000. And the problem here is that our interest rate is compounded quarterly. So the equation to find the effective interest rate looks something like this. So this allows us to convert our interest rate, I, nominal, to something that we could use for this cash flow diagram. So there's different ways to calculate the effective interest rate. I'll show you 2 ways so you get the idea. So let's first calculate the quarterly interest rate. So the quarterly interest rate can be defined as this. So we take 1 plus the nominal, which is 4%, and m could be how many times we want to divide this into. So we could divide it into weeks, months, quarters, and so forth. So let's say we divide the nominal interest rate into months. So let's divide by 12. So that means that this interest rate is now per month, and we want to figure out how many times we want to compound that within the entire time frame that we chose. So for this instance, we divided it by 12. So now this is per month. Therefore, if we want it per quarter, the effective interest rate per quarter, we would have to multiply by 3 or raise to the power 3, because that'll be 3 months, which would be a quarter. Now that's not the only way to do it. We could do it again. So this is 1 plus. Instead of dividing by 12, let's divide the nominal interest rate by 4. So now this is in terms of every 3 months. So how many times do we want to compound this every 3 months to get the quarterly interest rate? Well, we only want to compound it 1 time. So these values will give you the same exact effective interest rate. It's just based on how you define things. So you divided this by 12, which is a monthly nominal interest rate. And how many times do you want to compound that to get a quarterly interest rate? You want to compound it at least 3 times to get a quarterly interest rate. Hopefully that's not too confusing. And I'll give you roughly 1%. But that's still not useful because we need an effective interest rate that goes for 2 months instead of a quarter. So technically you didn't have to calculate the quarterly interest rate. I just did that for demonstration. So let's now calculate the effective interest rate for 2 months. So again, we use that formula. So 1 plus the nominal interest rate. So this is 4%. Now you could decide how you want to do this. So let's do the year first. So let's say we divided by 12. So now this is per month, and we want to compound this for every 2 months. So we raise this to the power 2 and subtract 1. Or we can do the quarterly interest rate instead. So this will be 1 plus 4% divided by 4. And how many times do you want to compound that every quarter? Well, if there's 3 months in a quarter and you want this on a 2-month basis, that means 2/3 of the time you want it to compound. And then you subtract 1. So these will give you the same approximate values. So this will be 0.00666. Okay, so now that we have that, this problem is pretty straightforward. All you have to do is basically plug in this effective interest rate of 0.6% into our equation. So we want to find this future value at the end of year 20. We'll call it F20, even though it should be F120 because it's in terms of 2-month basis, but it's fine. So we can say that F20 is simply The present value multiplied by the future given present of our effective interest rate per 2 months, 122 months every 20 years. And then we simply just plug this into our formulas, and then we get the future value, which is simply $548,593.23. So that is the future value if we invest $3,000 every 2 months with an account that's 4% per year compounded quarterly. Okay, so hopefully I didn't confuse you on how to calculate the effective interest rate. It is kind of complicated, but rewatch the video again if you have to and really understand what values you have to put here to calculate that effective interest rate that you're looking for so that it fits your cash flow diagram. With that being said, I'll see you in the next video.